Yeah, this is question number 16. Question number 16 said the magnitude of the resultant of two mutually perpendicular force F1 and what F2 is this. The magnitude of resultant force is what? 13. If the magnitude of F1 is this, what is the magnitude of F2? Look at the option given to us. What they mean, mutually perpendicular. Mutually perpendicular force means that they are at right angle to each other. Look at it. This is the mutual. If I take this to be what? F1, I take this one to be what? F2, then I can now put my resultant force, which is my resultant force, I can call it what? R. This means that my word by Pythagorean theory, I can now say this side is the force F2, this side is F1. I can now say that R squared is equals to what? F1 squared plus F2 squared, F2 squared. That's by Pythagorean theory. And what is my R? My resultant force is 13. They said my resultant force is 13. 13 squared is equals to F1. F1, the magnitude of F1 is a what? 5, which is a squared, plus the magnitude of what? F2, which is what? F2 squared, which I'm looking for. They say I should get the magnitude of what? F2. Then this will give me 169, and this man will give me 25. That's a 13 square will give me 169, 5 square will give me 25, plus F2 squared. Then making this subject of formula, I can say that F2 squared is equals to 169 minus 25. You know what I did? This 25 going over here become 169 minus it. I will have that what? F2 squared is equals to 144. Then here, I can now say that what? F2 is equals to square root of 144. And my answer for F2 is equals to what? 12. Nothing. Therefore, I now say that F2 is what? 12. Nothing. I can now go to the option here. Option A is not there. Option B is not there. Option C is the correct answer. I can answer my answer is what? Option C. Question number 17. Question number 17 said the component of vector x along the direction of vector y is 0 when x is at an angle of 45 to y. X and y are in opposite direction to each other. X and y are parallel to each other. X is perpendicular to what? Y. Let's just go to the question again. Let's see the question again. They said the component of vector x along the direction of vector y, the component of vector x along the direction of what? Vector y is 0. When two vectors have 0 component, when two forces have what? No component. We have condition for two vectors not to have a what? Component. Let's go to solution of this. Two forces will not have a component when they are not at an angle to each other. Look at it. Two conditions for what? For two forces to have 0 components. The two conditions. The two forces must be what? Y and what? X. Look at the first condition. Y, this is Fy, and this one will be what? F what? X. That means force of y, vertical force of y must be perpendicular to the what? X. That means y must be perpendicular to the what? X. That's the first condition. That means there are two of these forces are ray force. I think I told you the ray force we have the force that acts horizontal and the force that at what? Vertical. That's the two ray force we have. When the force is an inclined at an angle to either horizontal or what? Vertical, that force is not a ray force. That means that force must have a component of what? X and what? Component of what? Y. for its what real value. Therefore, the only force that have a component is force that incline at an angle, but the force that acts in perpendicular to each other will not have what components. Are you getting what I'm saying? Now they are not going to have components. This force y and force x has no what component. The only force that will have a component is the force that necessarily acting this way, which is at an angle to horizontal and an angle to what vertical. We resolve this force to have a component of x. We resolve this force to have a component of what y. But as far as the force acted vertically and what horizontal, it has no what component. And that's what we call real force. These two forces I stated here, this Fx and Fy, are real force. Then another condition for force, two force not to have a component. As far as they are in parallel, if force X is moving in parallel like this, which is what force what X, and also force what Y is moving in parallel with it, which is what force what Y. These two forces will not have a component because they are parallel to each other, and the angle between them is what 0. Are you getting what I'm saying now? The angle between them is what 0. So these two conditions for force not to have a component. If a force does not have components, it means that two forces are in perpendicular to each other, and the y must be perpendicular to what x. Y must be perpendicular to x, and another condition is that the two forces must be moving in what in parallel, so that they will not have a what component. So let us look at the option they give us. They said x at an angle of 45 degrees to y. That's wrong. X and y are in opposite direction to each other. That's wrong. And x and y are parallel to each other, which answer this question. They must be what parallel to each other for them to have a 0 component. Then D would have been the answer. D would have come nearer to the answer because they said x is perpendicular to y. No. Who is perpendicular to each other is what y is a perpendicular to what x. For this to not to have what component, y is a perpendicular to what x, not x perpendicular to y. So our option for the answer, is a what option what C. Option C is our answer. Like the x and y are parallel to each other, and that what made what y makes the vector to have what 0 component. I said the component of vector x along the direction of the vector y, component of x along the direction of the vector y is 0 when x and y are parallel to each other. Are you get what I'm saying now? Not when x is perpendicular, is y that will be perpendicular to x. So that's it. Our option C is the correct. That is the question number 18. Question number 18 says if the angle between two vectors P and Q is 0, the vectors are said to be perpendicular, be parallel, C intersects at an angle 60, D intersects at an angle 45. We have mentioned this in the other previous question we answered. The question we answered, which is question number 17, we answered. We talk about condition for a vector to be two vectors to have a 0 angle. For this, if the angle between two vectors P and Q is 0, it implies that they are parallel to each other. Only when two vectors, look at this force moving. When I say vector, I'm talking about force. I think you remember. Look at these two forces now moving this way, this one moving this way. The angle between two of them is what? 0. That's when they will have 0 component. And when these two forces are parallel to each other, they will have 0 component. There will not be any component of y or x of these two forces. So the only way they will have what angle to be what 0 is when they are what parallel to each other. And our option B, our answer, which is option B, is the correct answer. This is the question number 19. The question number 19 says two forces each of 10 Newton act on a body. Two forces each of 10 Newton act on a body. One towards the north and the other towards the east. Towards the north and towards the east. The magnitude and the direction of the resultant force are, look at the option they give us. Look at the option B, look at option C. Let's see the solution. They are asking us the magnitude and direction of it are, then the two forces are 10 nothing. They said they move north, one move north. Let me draw it here. One move north and one move what? East. And this one is 10 nothing. And this man is a what? As well, 10 nothing. And this thing I draw can be drawn this way. I can draw this way again, moving this way. And this man moved this way. Are you getting what I'm saying? And my resultant force came to cancel the effect. You remember? These two forces move. This man, I can take this man to this place. I take it though, it's a valid. That's what I do. I take this man to this place, which this man move and this man move. And my resultant force cancel the effect. And this is my resultant force. And this is 10 nothing. And this man is also 10 nothing. And this is the angle of direction of my resultant force, which is the angle which he made with horizontal. I told you that the angle of resultant force, the direction of resultant force is the angle which he made with horizontal. The direction of the resultant force is the angle which he made with what? Horizontal. And that's what I have given to you now. I cannot use Pythagorean to get my resultant force by saying that R, Pythagorean theory on this one, R is equals to what? 10 squared plus what? 10 what? Squared as well. Then I can now say that R squared is equals to 100 plus 100 as well. I can now say that R itself will be equals to square root of what? 200. I think you know. And this square root of 200 is same thing as what? Square root of what? 100 times what? 2 will give me 200. Can we come over here? You cannot say that my R is equals to what? Square root of 100 times square root of what? 2. And that will give me R is equals to square root of 100 will give me what? 10 times square root of what? 2. And the R will be 10 root what? 2. That's the magnitude of the resultant force. Then let me look at the direction of resultant force. You can come over here. Let me do the direction of resultant force over here. Direction of resultant force become opposite over adjacent, which will give me tan theta. Opposite over adjacent. For me to get this what? Theta. I will say opposite over adjacent will give me tan theta. I will now say tan theta. Tan theta is equals to what? Opposite, which is 10 all over what? 10. And that give me what? Tan theta is equals to 1. Then theta, which is equals to what? Tan inverse of what? 1. I don't have calculator. How will I know the tan inverse? Because we don't use calculator to write JAMB. Okay, let me remember. Let's see. I cannot bring out my diagram from my head, which I store in my head. What's that diagram? The diagram that goes this way, which I already mentioned before. This give me 45. This give me what? 45. This give me what? Root 2. This give me 1. This give me 1. Therefore, I cannot say that adjacent. That's give me root 6. This give me adjacent. Opposite over adjacent. Opposite over adjacent will give me tan 45. That means tan 45 is equals to opposite over adjacent. Look at opposite over adjacent. Give me tan 45. Therefore, tan 45 is equals to what? 1. Therefore, if tan 45 is equals to 1, it means that tan theta equals to 1 means that what? Coming over here, this theta is equals to what? 45. Therefore, I can say that theta is what? 45. Since tan 45 is equals to 1, it means that this theta, which is what? 45, is equals to what? 1. That's what we are talking about now. Therefore, I have gotten the direction of the word resultant force to be what? To be what? Theta. Therefore, if this theta is 45, what's direction? It's moving towards what? North. From north to what? West. North to what? East. It's moving from what? North to what? East. Look at it. It's moving from north towards what? East. Are you following me now? It's moving from north towards east. I can now say my resultant force is what? 10 10 root 2 north 45 east. That's 10 root 2 north 45 east. My option, my answer, looking at the option over there, I will say 10 root 2 45 east. And my option is what? Option what? B. Look at option B is our answer. Option B is our answer. Here is question number 20. Question number 20 says, the resultant of two forces acting on an object is maximal if the angle between them is dash A this, B this, C this, and D this. Let us look at, for a force, two forces to have a maximum resultant mean that there is no angle between them. Look at this. If these two persons now is pushing, I'm pushing this way and this person is pushing this way, we are going to have a maximum effect. If we are pushing a vehicle and I'm pushing this way, this person is pushing this way, this vehicle will be pushed away. Are you get what I'm saying? So for us to get a maximum what? Resultant force, the two forces must be acting in what? In parallel. And when they are acting in parallel, means that angle between them is 0. When the two forces, look at this vehicle, we are pushing it now. I'm pushing it this way, this person is pushing it this way. So we are parallel to each other, pushing it straight. And that means that angle between us is what? 0. So this is a condition for two forces to have a maximum what? Resultant force. The maximum resultant force of two forces, they must be what? In parallel. The two forces must be acting in parallel, which you call collinear forces. If this force is acting this way, this one is also acting this way, we are going to achieve a maximum resultant force. Are you getting what I'm saying now? So, but if a force is inclined at an angle, we are not going to get a maximum resultant force. So, for a force to have a maximum resultant force, if there are two, they must be in parallel to each other. And when they are parallel to each other, means the angle between them is what? 0. Then again, we remember again, there's a condition for a force that will be sat on an what? A wire moving in a magnetic field. If you now rule a wire in a magnetic field, there is a force that will be inserted on that wire or iron. The force that will insert on that iron, if it is moving in a magnetic field, will be maximum. This force will be maximum. Look at the force inserted is equals to what? The magnetic flux times charge times velocity sine what? Theta. So for this force, which will be inserted at what? A current carrying wire moving in a what? Magnetic field, the force that will be inserted on that wire will be what? Maximum when this theta is equals to what? 90. When this theta is equals to 90. And when this theta is equals to 90, sine 90 will give me 1. This means this force will be what? Maximum. This force will be maximum when theta is 90. The same thing is applicable when we are talking about range in a projectile. Range in a projectile, look at the range in a projectile is given as what? U squared sine 2 theta over what? G. This is the range, the formula for the range in a projectile. Formula for range in a projectile is given as this. And this range will be maximum. It will be maximum when this what? Angle of projection is equals to what? 45. When this angle of projection is what? 45. That's when this range will be what? Maximum. When this angle is 45, mean 2 times 45 will give me what? 90. And sine 90 will give me 1. And I will have that maximum range. Maximum range is equals to U squared all over what? G. Therefore, this range will be maximum when this theta is equals to what? 45. That's when we will get range to be what? Maximum. And this force will be maximum, force that will be inserted on and what? A current carrying wire in a magnetic field will be maximum when the theta is equals to what? 90. So this is the condition as well as we said here. So our option here for our answer will be what? Option what? B. Option B is our answer. When the angle between the two forces are what? 0. When the angle between the two forces is what? 0. We are going to, that's the question number 21. Question number 21 said a ball is moving at 18 meters per second in a direction inclined at 60 degrees to the horizontal. Full stop. The horizontal components of its velocity is dash. What they are asking us now is the horizontal component of that force. They said a ball is moving at 18 meters per second in a direction inclined at what? 60 degrees to the what? Horizontal. Let's go to solution. Look at the solution without wasting time. JAMB, there's no time. When I have, look at the horizontal, and that ball is inclined at an what? Angle of what? 60 degrees to the what? Horizontal. It's inclined at an angle of what? 60 to the what? Horizontal. And what is the force? The ball is moving at what? 1.8 meters per second. That's what the ball is moving with. It's moving with 18 meters per second. And this ball, we are going to resolve the velocity. What they asked us to resolve the velocity, they said what is horizontal component of its what? Velocity. The horizontal component of its velocity should be what? X. This fx, we don't know that what? When we are talking about fx, as I told you, that this thing you see now, if I do it like this, I will have what? Adjacent over what? Hypotenuse. Adjacent over hypotenuse. I will have that what? Adjacent, which is fx, over hypotenuse, which is 118 meters per second, is equals to what? Adjacent over hypotenuse will give me cos of what? 60. Therefore, fx, which is horizontal component of what? This horizontal component of 18 meters per second is equals to what? 18 meters times what? Cos 60. Remember that this is over 1. If you can remember that this is over 1, let me clear it here. This is over what? 1. Cross multiplication. I will have that fx is equals to what? 18 times what? Cos 60. This is cos 60. Then I will have, did I have cos 60 my what? I don't have a calculator. How will I know cos 60? I don't use calculator in JAMB. I will not go to remember my words. The triangle in my brain, I bring it out. This triangle in my brain, I bring it out to remember the triangle which we said here is what? 60, and here is 1, and here is what? Root 2, root 3. Here is root 3, and here is what? 2, and here is what? 30. If I want now cos 60, it will be what? Adjacent over what? Hypotenuse will give me cos 60. Cos 60 will be adjacent over hypotenuse will give me cos 6, which is what? Half. I can now say, come over here, I can now have 18 times what? Half, which is what? Cos 60. And 18 times half will give me fx is equals to what? 9. And that's what? 9 meter per what? Seconds. 9 meters per second. And I will go into option. I go for the option. I go to option A, option B, go to option C, and I see that option D is the answer. I will say my answer is what? D. That's my answer. That's the question number 22. Question number 22 says the resultant of two forces is 50. If the forces are perpendicular to each other and one of them makes an angle of 30 with the resultant, find its magnitude. Who are we finding its magnitude? That force that make what? 30 degree with the what? Resultant is what we are looking for its magnitude. Look at the question. The resultant of two forces is this. If the forces are perpendicular to each other and one of them makes an angle of 30 degrees with the resultant, find its magnitude. Solution. Let's go to solution immediately. Let's go to solution. I know, look at them, they are perpendicular to each other, and this is a resultant force, and this is angle what? 30. I cannot call this man to be what? Fx. And this man is a what? Fy. Are you get what I'm saying now? And they told me that the resultant force, which is equals to what? 50 Newton. That's the resultant force is 50 Newton. If I'm taking this, they are asking me to calculate what? The magnitude of the one that made this, which is this one, that make the angle 90 with the resultant force. Look at the force that made angle 90 with angle 30, I mean to say with resultant force. This man makes an angle 30 with resultant force. If I do this close, I cannot say adjacent over hypotenuse, which is this, over hypotenuse, which is r, is equals to what? Cos 30. And I can now say this is over 1, cross multiplication, I can now say that fx is equals to what? R times what? Cos 30. And what is r? My r is what? 50. Resultant force times what? Cos 30. What is cos 30? I don't have calculator. I will remember my word triangle I will say before. This give me what? This, which give me what? 60 here, and here give me what? 30. Here give me root 3. Here give me 1. This give me what? 2. Cos 30 is the what? Adjacent. Look at adjacent. The one the angle sitting on. Cos 30 is adjacent. Look at the adjacent to this 30. You over what? Hypotenuse. Cos 30 is adjacent over hypotenuse. Look at it. Look at where the 30 is sitting on. This where is sitting on is what? Adjacent over hypotenuse will give me what? Root 3 over what? 2. And this will give me equals to what? 50 times what? Root 3 over what? 2. And this will cancel this. And that will give me what? 25 root 3. And that means that fx is what? 25 root 3. Let's go to option. This is noted. Go to the option. I can see that option C is the correct answer there. Option C is correct answer, which is what? 25 root 3 Newton. That's the answer. I will say my answer is option what? C. Later, there is the question number 23. Question number 23 said a boat travels due east at a speed of 40 meters per second across a river flowing due south at 30 meters per second. What is the resultant speed of the boat? Resultant speed of the boat. You remember they said the boat traveled due east. Look at the boat traveling, going due east. The boat is traveling, going due east. And what happened? And that boat traveled with what? The speed of what? 40 meters per what? Seconds. And they across a river flowing due south. Look at the river flowing due south. And that river is what? Flowing with a speed of what? 330 meters per what? Second. That's the speed which is the river is used to be floating. Look at the speed which is the boat is used to be floating. They now ask me to calculate what is the resultant speed of the boat. The resultant speed of the boat is this. Look at the resultant speed coming over here. And here is the resultant speed. I can now say by Pythagorean theory this is 90. By Pythagorean theory I can say resultant speed is equals to 40 squared plus what? 330 what squared. And that's it. I think you know. That's what it means. And when I square this, I will have what? R squared is equal to 40 squared will give me what? 800. 4 squared will give me 1,800, 1,600, I mean to say 1,600 plus this will give me what? 900. And this man will give me R squared will be what? This plus this will give me, taking this to this will give me what? 2,500. Taking one from here, putting here will give me what? 100 will give me 1,000. That's give me 2,500. And this man is something as square root of what 2,500, and that will still give me that this is something as square root of 25 times what 100. I think you know. And this will give me r is equals to what root of what 25 times root of what 100. I think you know. And this will give me that my r is root of 25 will give me 5 times the root of 100 will give me 10, and this will be what r is equals to what 50 meter per what second. That's my resultant what velocity. The resultant what the resultant speed of the boat is what 50 meter per second. Looking at the option here, I can now say that option C is the correct answer. I can answer my answer is correct, is a what option what C. The option C is the correct answer there. This is the question number 24. Question number 24 said 2 cars moving in the same direction. 2 cars moving in the same direction have speed of 100 kilometer per hour and 130 kilometer per hour. Full stop. What is the velocity of the fastest car? Velocity of the fastest car as measured by an observer in the slower car. Look at the option given to us. I cannot say solution. We have to recall our relative velocity. The relative velocity, if a 2 car is moving in opposite direction, look at a car. This is a car now, moving this way. This car is moving this way, and another car, which is this one, another car is moving this way, another car is moving this way, another car is moving this way, this one is moving this way. They are opposing themselves. We say that their relative velocity of this man, which is A to what B, relative velocity of the car A to B is equals to what? Relative velocity is equals to what? A plus what? B. That is the relative velocity of A to B. Are you get what I'm saying? This is the relative velocity of what? A to what? B. And we represent it at what? This. Then, what of if the 2 cars is moving in the same direction? This car is moving this direction and this car is moving this direction. Means that the 2 cars is moving in the same direction. If they are moving in the same direction, watch. This car is moving this way, which I call this what? A. I call this one what? B. They are moving in the same direction. I cannot say they are relative velocity, the relative velocity of A in respect to what? B. The relative velocity of A in respect to B, which we'll write as what? R, relative velocity, I write it VR, relative velocity of A in respect to B, is equals to what? A minus what? B, because they are moving in the same direction. Relative velocity of A in respect to B is equals to what? A minus what? This one. Then I cannot say again relative velocity of what? B in respect to what? In respect to what? A. In respect to A will be what? VRB is equals to what? B minus what? A. B minus A. This is relative velocity of B in respect to what? A. This is relative velocity of A in respect to B when they are moving in the same direction. This is when we have. But when they are moving in opposite direction, look at their relative velocity. Then now, in this question, the 2 cars are moving in the same direction. Look at it. They said what? 2 cars moving in the same direction. two cars moving in the same direction have speed of 100 kilometer per hour and 130 kilometer per hour. Full stop. What is the velocity of the fastest car? Velocity of the fastest car as measured by an observer in the slower car. What is the relative velocity of faster one? Relative velocity of faster one in respect to what? Observer in the slower one. That means I will now say relative velocity V R of the faster one F is equals to what? Which one is the faster one? 130 is the what? The faster one compared to what? Minus what? 100 kilometer. And this will give me the relative velocity of the faster one is equals to what? This minus this will give me what? 30 kilometer per hour. I will go to my option and look at that on my option. Look at option A, look at option B, look at option C, and I find out that my option D is the correct answer. I can now say my answer is a what? D. That's the relative velocity of the faster one in respect to what? The slow one. And there is question number 25. Question number 25 says the motion of the moving skin of a talking drum can rightly be described as the motion of the moving skin of a talking drum can rightly be described as translation, random, rotational, oscillation. The skin, when you put it brickety, how does it move? He what? Oscillates, just like a jitter is or what? Oscillates. So our answer here is oscillation motion. This skin, when you beat it, they say the motion of a what? Moving skin of a talking drum is what? Oscillating. We said is a what? Our answer here should be what? Our answer is what? Oscillation, which is our option D. Option D, which is oscillational motion. The drum we are beating keep on what? Vibrating. That means oscillating. That's as is oscillating. We call it what? Oscillation. That's the talk of the drum. And that our answer is option what? D. So let's go to question number 26.